Hi, in this video we're going to be talking about inscribed angles. So inscribed angles are a little bit different than central angles. In this diagram right here, I've got a central angle, angle ROM, which is a central angle because it goes through the center of the circle. An inscribed angle doesn't. An inscribed angle has one of its vertices on the edge of that circle. So the inscribed angle would be angle REM. Those both make intercepted arcs. So both this central angle here and that inscribed angle here both intersect this arc out here. So that would be RM. And to show that it's an arc, we kind of draw a little arc right above it. Now, what's cool about those is if you have an inscribed angle, that equals half of whatever this arc is. So you can just kind of cut arcs in half, and that's the same as the size of the angle. So right here, if this is A, then this thing out here is 2A, which is the same as the uh, central angle. So let's try that out in this diagram here. I've got this arc over here, and then this inscribed angle right here. So since this is intercepting this arc, I know that angle J needs to equal 40 degrees. It's got to be half of whatever that arc was. Now that's not actually helping me find any of the angles. I'm looking for maybe X. So I've got this big arc here, which is being intersected by this angle down here. So this is the measure of my angle, and I know it should be half of that arc. So our angle in this case is 63 degrees, and our arc is these two angles added together. So that's got to be 80 plus whatever x is. And now I've got an equation that I can solve for x. So I could distribute that. I don't want to. I'm just going to get rid of it by multiplying both sides by 2. So that gets me 126 equals 80 plus x. I could have distributed. I would have eventually gotten the same answer. Subtracting an 80 from both sides, we get 46 equals x. Great, I've got one of my angles. Another angle I see right here is Z. Z is almost intersecting this arc because it's not going all the way to the edge of the circle. So I can't quite do that theorem there. I got this y over here as well, and this y is doing that good inscribed angle intersected arc, but I don't know what this is, or do I? Look, I've got all of these angles going around the outside except for this angle right here. And there's got to be 360 degrees in a circle, so I could use that to find my missing question mark. I could say that question mark plus 113 plus 80 plus 46 plus 89, that's got to equal 360. So if I add all these up, I get 328 equals 360. So I could subtract that 328 from both sides. And that missing arc is going to be 32 degrees. Great. So if that is 32 degrees, then this angle has to be half of the arc. So y has to equal half of 32. So that means y has got to be 16 degrees. The last thing I got to get is this angle Z right here, but now I know all kinds of things about this triangle. If I found out what this angle was, it should be the same as Z. These two are vertical angles, so I can find Z by using the little triangle that's inside of there. So I can say that 16 plus 63 plus z has got to equal 180 degrees. So that is 79 plus z equals 180. So that must mean z equals 101 degrees. And that's all done. So some other corollaries that kind of go along with this idea of cutting things in half is this idea that opposite angles of a quadrilateral inside of a circle are supplementary. So we know that these two angles here are 180 and these two angles here are also 180. So that's a real quick solve in order to get us x. So x plus 76 has got to equal 180 degrees. So that must mean x equals 104 degrees. Great. Nice quick start. Using the same idea from the front, if this is 104 and we're looking for this arc out here, we can say that 104 has got to equal half of whatever 96 plus y has got to be. So if I multiply by 2 to get rid of this fraction, we get 208 equals 96 plus y. That tells us that y has got to equal 112 degrees. The last thing we need to find in this shape is z, and we can use that same trick that we did before. Here is our big arc, and then it's intercepted by this angle. So we can say that 82 has got to equal 1/2 of whatever 96 plus z has got to be. So multiplying both sides by 2, we get 164 equals 96 plus z. Subtracting a 96 from both sides, z ends up equaling 68 degrees. Now this next one gives us something kind of quick and easy. If we've got a semicircle, so that is half a circle, then this ends up making nice little right triangles in our circle. So here we've got a inscribed angle hitting a semicircle. Here's another inscribed angle hitting a semicircle. So we can really quickly say that W equals Z, which equals 90 degrees. So we just got two of our angles with that one statement. We've also got a nice inscribed angle right here that's hitting that X. So we can say that that angle 24 has got to equal half of whatever that arc measure is. So multiplying both sides by 2, we get 48 equals X. Cool. So we're moving right along. Last thing we got to get is this Y down here. That y is coming from this intercepted angle, which we know is 90. We also know that it's half of that circle, so really we just got to double that 90. Y has got to equal 2 times our 90 degrees, which is 180 degrees. Now the angles we have been looking at have been inscribed angles, so they're all inside of that shape. So these angles are outside of that shape, but we do have a nice tangent line that's only touching our circle once. It is still doing the property that this arc is half of this angle. This arc right here is going to be half of whatever this angle is here. So right here, where I've got this angle, that angle has to equal half of our arc. So our arc is that x, our angle is 74. So to figure out what x is, we just multiply both sides by 2. So 148 degrees equals x. We've also got to figure out what y is going to be. So to figure out what y is going to be, we just say, hey, there's 360 degrees of arc in a circle. So that's going to be our 148 plus whatever y ends up being. So we just got to subtract 148 from both sides. And y ends up equaling 212 degrees. And that's it for our video. The main thing I want you to remember is this inscribed angle theorem, that angle has got to equal half of our arc. If while you're working you write this down, I think that would be a really good idea of writing angle equals half arc. And then you can plug in your values where they go and then solve that equation. Just always write that equation, angle equals half arc. Thanks for watching. Bye-bye.